Hello everyone, this is Suvendu, your physics mentor, and welcome to our chapter current electricity. And in today's class, we will discuss the part 2. So in part 1, actually in part 1 we have discussed the concept regarding our current, electric current, what do you mean by electric current, and types of current we have discussed, along with so many important numericals we have already discussed. So in this lecture number 2 or part 2, basically we will start the mechanism of current flow in a conductor. After that we will discuss the Ohm's law, a drift velocity, relaxation time, Ohm's law, everything. So without any delay, let's start our topic. So our topic is mechanism of current flow in a conductor. So we know when a conductor is not connected with battery or cell, in that case we know the amount of current is zero. But when conductor is connected with battery or cell, when two ends of the conductor is connected with battery or cell, then current value will be not equal to 0. So what is the reason behind this? I is equal to 0 and I not equal to 0. What's the reason? And what's the concept actually? Now see one thing. Let us think about this diagram. Let us think this is your current carrying conductor. Let us think this is our current carrying conductor of length L. L is the length of the conductor. So in case of a solid, the atoms and molecules are tightly packed. We know this thing. In solids, atoms and molecules are tightly packed. Second thing, the outermost orbit of the electron, the outermost orbit of or outermost orbit electron of an atom, that is stated as free electron, and that is free to move within the volume of conductor. But the outermost orbit electrons are free to move within the volume of conductor. Within the volume of conductor. So they are called free electrons or mobile charges Is that clear to all of you? Yes. Now we will consider the case when the conductor is not connected with battery or cell. Now this is current carrying conductor, but it is not connected with battery or cell. So what is going on actually? Remember, at room temperature, that is 27 degrees Celsius or 300 Kelvin. All the thermal velocity of electron, nearly 10 to the power 5 to 10 to the power 6 meter per second. This is as per which formula? We know V RMS is equal to 3 kBT divided by m root over. 3 is constant, kb is for Boltzmann constant, absolute temperature, okay, temperature in Kelvin, then mass of the electron. By putting the respective value, we will get this is nearly equal to 10 to the 5 meter per second. So what is the thermal? What is the order of thermal velocity of electron? You have to tell it is 10 to the power 5. It is 10 to the power 5 meter per second at room temperature. So remember one thing, what is going on? So now all the electrons are in motion actually. But why the current value is 0? That is our question. Why the current value is 0? So now see, this is suppose your conductor. This is suppose your conductor, current carrying conductor. Very good. Now see, in this current carrying conductor, if you will consider any cross section of conductor, let us consider any cross section of conductor, then experimentally it has been found that at any cross section of conductor in time t, the number of electron crossing through this cross section from left to right, number of electron passes through this cross section from left to right. All the electrons are in zigzag motion or random motion. Thermal speed 10 to the 5 meter per second. Number of electron crossing through any cross section in time t from left to right is equal to number of electron crossing through that cross section. Number of electron crossing through that cross section from right to left is same. That means जितना number of electron ये क्रॉस सेक्शन को क्रॉस कर रहे हैं फ्रॉम लेफ्ट टू राइट इन टाइम इंटरवल t सेकेंड, same number of electron passes through this cross section from right to left. That's the content. So electrons are in zigzag motion. First thing, all the electrons are in zigzag motion. First point, all the electrons are in zigzag motion. The motion of electrons are so oriented that the motion of electrons are so oriented that number of electron passes through any cross section of conductor from left to right in time t second is equal to number of electrons passes through that cross section from right to left, from right to left in time t second. So due to this, what is the net average velocity of all the electrons about this cross section? Thus net average velocity of all the electrons, net average velocity of all the electrons about any cross section of conductor is 0. बुझिला ठीक से? सपोज मु कहबी ए इलेक्ट्रॉन रो वेलोसिटी हला 10 to the power 5 meter per second from this side left to right. So a electron रो केते हला 10 to the power 5 meter per second velocity. Here for this electron it will be minus 10 to the power 5 meter per second. तो इन दोनों का एवरेज क्या होगा? That will be 0. Like this, इस सारा का सारा इलेक्ट्रॉन का जो एवरेज वेलोसिटी that comes out 0. तो इसका एवरेज वेलोसिटी लेट इट बी u1 वेक्टर. This is suppose u2 vector, u3 vector, u4 vector, u5, then this is un vector. Let us consider n number of electrons. Total number of electrons are n. So from this content we came to know net average velocity of all the electrons about any cross section of conductor is 0. That means u1 vector plus u2 vector plus dot 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 plus un vector divided by total number of electrons, that gives out 0, which implies current through the conductor, is 0. Electric current through the conductor is 0. Clear? Electrons are in motion, but they are in zigzag motion, and their motion is not in one direction. All the electrons are having different velocities. Clear? Because of this zigzag motion or Brownian motion or random motion. So because of this reason, when conductor is not connected with battery cell, we will get the electric current value, that is 0 value. So now think about when the conductor is connected with battery cell. When conductor is connected with battery or cell. So what will happen? That is our content. So now we'll focus upon how current constitute when the conductor is allowed to connect with the battery or cell. 1 minute. So here, what we will discuss? Let us think this is our conductor. Let us think this is our current carrying conductor, and it is now connected with battery or cell. Let us think this is battery. Combination of cells in series is termed as your battery. When the conductor is connected with battery, what you will observe? Let us think this end is X, this end is Y. So this is positive, this is negative, that is this one is your higher potential, this one is your lower potential. So end X becomes higher potential region and end Y becomes low potential region. So a constant potential difference is maintained across the two ends of a conductor when the conductor is connected with battery or cell. And let L is the length of the conductor. And in that case, an electric field is established from higher potential to lower potential. And because of this reason, this electric field exert force upon this electron. And due to the presence of electric field, electrons present inside the conductor, that is free electrons, they experience as a force. They will experience as a force. And due to the presence of electric field, because of the force exerted by electron, all the electron starts to move from lower potential to higher potential region. ना आइडिया सबको बुझिएला ठीक से. What is the direction of electric field? Higher potential to lower potential. What is the direction of motion of electrons? Lower potential to higher potential. So now what we will write? So when conductor is connected with battery or cell, a constant potential difference is maintained across its two ends. Is maintained across its two ends. Ready? So in figure, end X is our high potential region. And end Y, this is our low potential region. Okay, is that clear to all of you? Yes. So what will happen? Due to this region, an electric field is established. The direction of electric field is from higher potential to lower potential. Next one is direction of electric field. is from higher potential to lower potential. Then direction of motion of electron. Direction of motion of electron. That is from lower potential to higher potential. I think it is clear to all of you. Because of the presence of electric field, electrons experiences a force and they starts to move from lower potential to higher potential. So here we have to write because of presence of electric field, all the electrons start move from lower potential to higher potential. Clear? Which implies electron experiences some force due to electric field. Which implies electrons gain some extra energy. Clear? But during their motion, they collide with other electrons. So in that time, what will happen? During motion, electrons collide with other electrons and positive ions. So their energy gets decreased. So their energy gets decreased. Clear? That means due to the presence of electric field, electrons gain some extra energy. They experience a force. They start to move from lower potential to higher potential. During their motion, they will collide with other electrons and positive ions. What will happen? Then that extra energy gets destroyed. Then extra energy gets destroyed. Gets decreased or destroyed. Gets destroyed. And due to this reason, what will happen after this case? Due to the constant potential difference and due to continuous electric field, again electron starts to move. Again the electron starts to move. ये चीज को याद रखो. Okay, during the motion, electron gets extra energy. But what will happen? This extra energy lasts for very less time. Okay. That's the content actually. The content is telling electron gets extra energy. They starts to move from lower potential to higher potential. During their motion, they suffer collision. Due to this reason, that extra energy gets destroyed. But due to continuous effect of electric field, but due to continuous effect of इलेक्ट्रिक फील्ड, बैटरी तो अटैच है ना, पोटेंशियल डिफरेंस इज मेंटेन, इलेक्ट्रिक फील्ड इज एस्टैब्लिश्ड, इलेक्ट्रिक फील्ड इज present, though the extra energy gained by the electron is now being destroyed. What are due to continuous effect of electric field? Electron again starts to accelerate, which implies inside the conductor the motion of electron is just like pause and start motion. I mean to say, inside the, which implies inside the conductor, motion of electrons, motion of sorry, motion of electrons are are just like pause and start motion. Pause and start motion. यही है story inside the current. So thus we came to know when conductor is connected with battery or cell, and electric field is established from higher to lower potential, electron start to move from lower to higher potential. Okay, then pause and start motion का story भी पता चल गया. That means due to this unidirectional flow of electron, current is established. Due to this unidirectional flow of electron, due to this unidirectional flow of electrons, electric current is established. Electric current is established. I think it is clear to all of you. So what is the role of battery or cell? Battery or cell provides a constant potential difference. Battery or cell provides a constant potential difference across the two ends of a conductor. That's the point. Battery or cell provides a constant potential difference across the two ends of a conductor. Across the two ends of a conductor. This is the region. This is the main thing. What will happen when battery or cell is connected to a conductor? How electric current is set up inside the conductor, we have already finished within this lecture. So starting from when conductor is not connected with battery or cell, mechanism of current. Okay, when conductor is not connected with battery or cell, what will happen? And after the connection, what you will see? You will see the electron starts to move from lower potential to higher potential. That is my point. So after this, what we will discuss? After this, what we will discuss? We will discuss about that motion. All the electrons starts to move from lower potential to higher potential. And don't think that velocity is very high. Don't think that velocity is very high. All the electrons starts to move from lower to higher potential with certain velocity. That velocity is called drift velocity. Drift means to move. Clear? So electrons drifted from lower potential to higher potential. So now we will discuss the long question, that is drift velocity. So our next content is drift velocity. Our next content is drift velocity. It is denoted by d vector. That means it is a vector quantity. So what's the content? What is the content? Now just have a look upon this content. I know this is fully important. We all know this. This may come as your question. Is that clear? So let us think this is your conductor. This is your current carrying conductor. And is connected with a battery or cell. Is connected with a battery or cell. think the diagram is clear to all of you. And let us think. Here the battery is attached and this is the key. So this is positive, this is negative. This end is X, this end is Y. And electric field direction is from higher potential to lower potential. This one is higher potential, this one is your lower potential. So what is the length of the conductor? Length of the conductor is L. What is the area of cross section of conductor? Let A is the area of cross section of conductor. Another thing in this figure, what is the direction of motion of electrons? Electron starts to move from lower potential to higher potential. Lower potential to higher potential. So now what we have to write? We have to write when conductor is connected with battery or cell, with battery or cell, electron starts to move from lower potential to higher potential. In this case, the average velocity of all the electrons after the connection with battery or cell, okay? The average velocity of all the electrons when the conductor is connected with a battery or cell is called drift velocity. Yes, so now we will write the definition of VD, drift velocity. The average velocity with which all the electrons gets drifted from lower potential to higher potential when lower potential to higher potential when conductor is connected with battery or cell. Conductor is connected with a battery or cell. It's called drift velocity. I think this thing is clear to all of you. This is the meaning of drift velocity. Now we will find the mathematical expression for drift velocity. Okay, is that clear to all of you? Now see. Mathematical expression. Mathematical expression for VD or drift velocity. Mathematical expression. So due to the constant potential difference between x end and y end, and due to the presence of electric field, the force experienced by the electron, what will be the value? So here we can write due to presence of electric field, the force experienced by electron is, what is that force? We know E vector is equal to F vector by Q. That means F vector equal to Q into E vector, and charge of electron we know is minus E into E vector. तो F vector को हम लोग क्या लिख सकते हैं? M into A vector, that is equal to minus E into E vector. So what is the acceleration of electron? Minus E vector by. So this is the acceleration of electron. This is the acceleration of electron. Is that clear? Okay. Let for first electron, U1 is the initial velocity of first electron. तो इसको भी कंसिडर करना है हमको for the mathematical derivation. Let U1 vector, it is the initial velocity of first electron. Now how many electrons are there? Let it be n number of electrons, capital N number of electrons. What is A vector? Acceleration of all electrons becomes equal. Charge of electron, electric field and mass are constant. So this is A vector will be acceleration of first electron. Is that clear? Next. Let V1 is the final velocity. फाइनल वेलोसिटी कितने टाइम के बाद होगा ये भी सोचना है हमको. फाइनल वेलोसिटी ऑफ फास्ट इलेक्ट्रॉन. तो कितने टाइम पर आफ्टर व्हाट टाइम द वेलोसिटी बिकम्स v1 वेक्टर. लेट tau1 is the time interval when time interval for the motion of electron between one collision and its next collision. सपोज यहाँ पे इलेक्ट्रॉन ऐसे मूव कर रहा है. दिस इज योर इलेक्ट्रॉन. इट सफर्स collision with this electron. After this electron travels to this. Now electron suffer collision at this position. So the time interval between these two things, that is tau1. Time interval between two successive collisions. So time for which electron moves from or electron suffer one collision and its next collision. Yes. So time of travel of electron between two successive collisions. From this, as acceleration is constant, we can use equation of motion. So from equation of motion, what we can write? Thus, v1 vector will be equal to u1 vector plus a vector 1. Vector symbol बोलते represent करिए हमको दरकार. v1 vector equal to u1 vector plus a vector tau1. Similarly, we can write what? Thus, v1 vector is equal to u1 vector plus a vector tau1. So similarly, we can say v2 vector will be equal to u2 vector plus a vector tau2. Like this, what is vn vector? Vn vector will be un vector plus a vector tau n. So now, what the drift velocity expression is telling to us? What the drift velocity expression is telling to us now? Now see one thing. Thus, drift velocity is the average velocity of all the electrons. So v1 vector plus v2 vector plus dot 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 plus vn vector divided by n. This is the average velocity of all the electrons. This is the final average velocity of all the electrons when conductor is connected with battery cell. So put the respective value. What is v1 vector? u1 vector plus a vector tau1 plus u2 vector plus a vector tau2. Like this. Finally, we can write un vector plus a vector tau n divided by n. This is divided by. So now what we can write? A plus b by c, we can write a by c plus b by c. So like this we can write it as, after simplification, splitting process add karo, u1 vector plus u2 vector plus dot 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 plus un vector divided by n plus a vector tau1 plus a vector tau2 dot dot up to a vector tau n by n. फिर से कॉमन आ जाएगा ए वेक्टर, तो ए वेक्टर दैट विल बी tau 1 plus tau 2 plus dot dot plus tau n divided by n. So what's the value of this first expression? This is 0. This is the average velocity of all the electrons before the connection of battery or cell with the conductor. So remaining term will be a vector, and let us think this is your tau average. What is tau average? Average relaxation time, or simply denoted as tau, is equal to tau. So here tau means average relaxation time of all the electrons, because it is the average of all relaxation time. Average relaxation time of all electrons. So now we came to know what is relaxation time. Time interval between two successive collisions. That is relaxation time. So a vector tau. What is a vector value? A vector value क्या था देखो. A vector will be our minus e vector by m. So now we can write a vector equal to minus e capital E vector by m into tau. This is the value of d vector. This is our mathematical expression for. This is the mathematical expression for drift velocity. I think this one is very clear to all of you. This one is fully clear to all of you. This is how to derive the mathematical expression for drift velocity. Now we will discuss some important points regarding this drift velocity. So listen properly, all of you listen properly. So in note point we can write, first point in vector form. In vector form, Vd vector is equal to minus E vector tau by m. Thus, Vd vector is anti-parallel to minus E vector. So theta between them is 180 degree. Then second point देखो, second point क्या है? In magnitude. What we can write? Vd is equal to E capital E tau by m. E capital E tau by also बुझिएगा. This is your drift velocity का magnitude. Now we can write what is Vd equal to, we know E is equal to dV by dr. E equal to dV by dr. So in our figure, the constant potential difference V is maintained across the length, across the two ends of conductor, and that length is L. So we can write E equal to in magnitude V by L. So because of this formula, we can write E into V by L into tau by m. Thus, this is another expression in case of magnitude. So from these two equations, we came to know Vd is proportional to E vector. So Vd is directly proportional to E. Vd is directly proportional to V. Vd is inversely proportional to length of the conductor. So keep this thing in mind. This is your third point, and this one is fourth point. This is about our what? Drift velocity. Next is relaxation time. What is the meaning of relaxation time? Time interval between, average time interval between two successive collisions. We have taken tau means tau average. So relaxation time, that is tau. So average time interval between, it is the average time interval between two successive collisions. It is the average time interval between two successive collisions. This portion is very important. Okay, you will face numerical or theoretical question from this portion compulsorily. So this is about our drift velocity and relaxation time. So now we will derive one 2 mark question. What is that? Relation between electric current and drift velocity. That is fully important for us. Now see that content properly. So relation between, now see, our next heading is relation between electric current, relation between electric current and drift velocity and drift velocity. What is that relation? So how to derive the relation? Now all of you see properly. So let us consider that same diagram. Okay, this is your current carrying conductor. This is our current carrying conductor, and its two ends are connected with a battery or cell ring which maintains a constant potential difference across the two ends of the battery. Is that clear? Okay. So what is the length of the conductor? L is the length of the conductor. Electrons, direct drift velocity of all the electrons, drift velocity of all the electrons, direct directed from lower potential to higher potential. And X is your higher potential and Y is your lower potential. Electric field direction, higher potential to lower potential. And what is A? A is the area of cross section of conductor. Okay, सब जिन सब लिखिया पड़िबो with systematic. With systematic you have to write all these things. Then how कौन रहिला? Let small n is the number density of electron. ये क्या दिखाया जा रहा है? एक यूनिट वॉल्यूम में कंसीडर कर रहा हूँ. तो यूनिट वॉल्यूम पे हाउ मेनी नंबर ऑफ इलेक्ट्रॉन्स आर अवेलेबल? लेट इट बी स्मॉल n. That is called number of electrons present for unit volume, which is called as number density of electron. So now we can write. Let L is the length of conductor, and A is the area of cross section, of conductor, Next is the electric field from higher potential to lower potential, and Vd drift velocity of all electrons. It is the average velocity of all the electrons. And let n is the number of electrons present in unit volume, which is termed as, that is, number density of electrons. That is our number density of electrons, other name. So now, can you tell what is the volume of conductor? Now, thus, volume of conductor, that will be our, how much? A into L. But what is L? If the speed is equal to distance by time, we know speed is equal to distance divided by time. That means velocity of all electrons, Vd. So electrons, average velocity of electrons, all electrons. So electron one end से लेकर other end suppose जा रहा है, lower potential to higher potential. So what is the distance advances by the electron? That is L. In time t, we can write L is equal to Vd into t. So instead of L we can use A into Vd into. This is the volume of conductor. And in one volume, number of electron is just, that is n we have accepted. यहाँ पे लिखा हूँ मैं volume, then number of electrons present. We have assumed in one volume number of electrons is n. What is the total volume? A into Vd into A into T. So Vd into A into T volume, number of electrons will be n into Vd AT. This is about the number of electrons present in total volume of conductor. Is that clear? Okay. What is the charge of electron? We are deriving the relation between current and drift velocity. Current is a scalar quantity. So we have to accept the magnitude of drift velocity. Okay. So we have to derive by considering the magnitude part only. So this is the total volume of conductor and this is the number of electrons present. Now you tell charge, sorry, यहाँ पे लिखो number of electrons, next table number of electrons, next is their charge. What is that? Number of electrons 1, the charge is E. Number of electrons N VD A T. What is the charge? E into N VD A. Unitary method only. I am focusing upon unitary method. I think this part is fully clear to all of you. This part is fully clear to all of you. दिखाई दे रहा है सबको? तो आराम से number of electrons charge 1 electron charge E, NVD80 electron E NVD80, that is the total amount of charge. Okay, so this is equal to Q total. We can write this is equal to Q total. Now we can say what is current? Thus I is equal to Q total divided by T, which implies I is equal to what is Q total? ENVD80 divided by T. After cancellation, what you will get? You will get I is equal to ENVD. So shortly you can remember it as I equal to VD ENA. Vina. I is equal to VD ENA. So you remember this formula, I is equal to Vina VD ENA. This will help in our upcoming numericals. So this is the relation between current and drift velocity. I think this part is fully clear to all of you. Yes. So after this, what we will discuss? इसका numerical हम लोग बाद में करेंगे. Okay. Numericals related to drift velocity and your relation between current and drift velocity, that will be discussed in another classes. So after this content, what we will discuss? We will discuss basically Ohm's law. Ohm's law and what is the meaning of linearity of IV graph and VI graph. What is Ohm's law? That will be discussed. Factor separating. Then inside the Ohm's law, we will get the resistance. And what is resistance? It's a unit dimension. Next is our factor separating resistance. That part we will discuss in next class. So this is about today's class. What is the thermal velocity? We came to know. So यहाँ पे याद रखो order of thermal velocity, order of thermal velocity, that is nearly equal to 10 to the power 5 meter per. So what is the order of relaxation time? Order of relaxation time. What is that? 10 to the power minus 4. So keep this thing in mind. Okay, this will help you in your one more question. So this is about our content which tells us about the order of drift velocity. We have discussed with the formula. What is that formula? V equal to 3 VRMS equal to 3 kBT by 3 kBT by R. In that case, we can write 3 kBT by R ne T, 3 kBT by T. So with this, we have completed our classes. Okay. Is that clear to all of you? Next is order of a drift velocity. We have to think. Order of another thing. Order of drift velocity we have to order of drift velocity. What is that? This is nearly equal to 10 to the power. Sorry, यहाँ पे -4 meter per second. This is -14. Okay. Order of relaxation time 10 to the -14 second. Order of drift velocity 10 to the power -4 meter per second. So with this, we have completed our lecture number 2. In lecture number 3, we will discuss the Ohm's law. Okay. कितना time हुआ? ठीक है. So this is about our classes, today's class. So thank you and have a nice day. Wait for the next classes. So please like, share and subscribe this channel for the better development of the students.